Hello everyone. I am Praveen PR, Assistant Professor, Department of Electrical and Electronics Engineering from Vidya Institute of Technology, teaching you all microcontroller lab programs for 5th semester electrical students under VTU syllabus. The subject code is 1518EEL57. Now, let us see how to perform the third program, that is, write an assembly language program to transfer 5 bytes of data from the memory location 8100H to the destination address 8200H. The source address is 8100 and the destination address is 8200. So once again, I'm repeating, we are writing an assembly language program to transfer 5 bytes of data from the memory location 8100 to the memory location 8200. To perform this, again, I'm using microcontroller microvision keel software. In the keel software, I will be again using what we call it as in the menu bar, the fourth one, that is project. Click on new microvision project, the file name as program3, click on the save button, click on 8089C51, 8089C51 ED2. So this is the microchip that we are using for performing 8051 microcontroller assembly language programming experiments using Keel Microvision software. So you use this microchip called 8089C51ED2. I'll click on OK. Since I am not interfacing it with the external device, I do not have to copy the image. I need not use any other software to check the result. I can check the result in the same software. I am going to click on no. So the target is created for the third program. Now I have to edit the program, type the program. It has been done in this window called edit window. To select this editing window, choose file, choose new and type the program. So I'm typing the program. This is the program which informs us how to transfer 5 bytes of data from the memory location 8100 to the memory location 8200. So after typing the program, I will go to File. I will click on Save As. I will type here as program3.asm, which says that I am typing assembly language program. I will click on Save, which indicates that the registers are given in green color, the opcodes are given in blue, and data is indicated in red. Now let us see how to execute this program. To execute this program, right click on target 1, choose options for target 1. The crystal frequency by default is 30. You have to set the crystal frequency to 11.0591 megahertz. Go to the output tab here, choose create hex file, click on OK. Now expand target 1. You find source group 1. Right click on source group 1. Choose add existing file to group to add your assembly language program to the given project. Kindly choose program3.asm under the file name and click on add once, which indicates that you have added the program that is the assembly language program, to this project. Next, we have to perform the translate, build and rebuild to check whether there are any errors in the program. So I click on translate. I find in the output window that there are no errors. I click on build. It links the hexa file. Next, I click on rebuild. It completes the compilation. After this, I will go to debug. I will click on start stop debug. I will click OK in this dialog box. It will take me to the output window. Here, once again, I'll click on view. I have to choose two memory windows here. One memory window called memory 1, which is going to show the input window. One more window, which is called memory 2, which shows the output window. So once again, I'll go to this memory 2. So memory 1 is the input window. Memory 2 is the output window. The memory 1 input window starts from 8100H. 5 datas have to be entered. So I enter 5 datas like AA, the next data BB, next data CC, fourth data DD, next data EE. In the memory 2 window, I give the memory destination address as 8200H. I enter again 5 values. The 5 values are 11, 22, 33, 44, 55. Any 5 values can be given, but it has to be a hexadecimal number. So let us see how to execute the program. So the data that is present in 8100 will go to 8200. The data present in 8200 will go to 8100 in this program. So to do this, let us start execution. The step 1 here is to press F11 button. So when I press F11, it asks for the counter value. So counter value here is 05, which indicates that I have fed 5 values in one memory location, 5 values in another. So totally 5 values are the one which are transferring from one memory location to another memory location. So in the specified program, it will say how many values you have to transfer. So if in the question 5, here you have to enter 5. If it is 10 data, you have to write it as 0A. Depending on how many data you're transferring, your count changes here. But again, I can use R7 as the register, R6 as the register, or any register from R0 to R7 can be utilized. Now, my destination address is 8200. So I'll be using two registers to store the destination address. So R3 will store the 82 and R4 will store 00. So 8200 is the destination address, 8100 is the source address. So R3 and R4 will store the destination. R1 and R2 will store the source. So R3 is storing 82 here. R4 is storing 00. So as you see, initially all will be 00. When I execute it in this way, your R7 will store 05, which indicates that it has taken the count value. R3 has taken 82. R4 has taken 00. Now your data pointer is pointing towards the memory location 8100. The data present 8100 is AA. So it points towards 8100 memory location. Next, what happens? The data from 8100 is collected and put into the accumulator. So like this 5 times I have to do. So I create a loop. So now the data present in 8100 is AA, which will be moved to accumulator. So you can observe your accumulator became AA. Accumulator is usually used for transferring the data from the data pointer or from the external memory inside the microcontroller. So accumulator cannot be always occupied. Hence, I transfer the data from the accumulator to any of the registers which are unused. So I use R5 as the memory register, which stores the data that is present in the accumulator. So when I say move R5 comma A, what does that instruction do? The data that is present in the accumulator will be moved to register R5. So you can observe here AA is moved to R5. So my first data is present in R5. Now 81 will be stored in a register R1 and 00 will be stored in register R2 because DPH and DPL is the higher and the lower bit of the data pointer. The higher bit information of the data pointer will be stored in register R1. The lower bit information of data pointer will be stored in register R2. So you can observe here your R1 becomes 81 and R2 becomes 00. Now my data which I need to transfer is present in R5. Now I have to fetch one more information. Which is that information? I have to go to 8200. How do I take 8200? I have stored 82 in R3. I have stored 00 in R4. So my data pointer, if it has to point towards 8200, I say move DPH comma R3, which says your data pointer will be pointing towards 82 and DPL R4 means 00 will be stored in DPL. So your data pointer will be pointing to 8200 memory location. Next, it is the data that is present in 8200, that is 11, will be moved to accumulator. So the data will be moved to accumulator. So one data is present in accumulator, one data is present in register R5. So my next instruction is to exchange. When I say exchange, the data present in accumulator will be transferred to R5 and the data present in R5 will be transferred to accumulator. Now, where should I put AA? To 8200. Your data pointer is pointing towards 8200. So the first data will be moved. So you can observe in the memory window too, instead of 11, you have AA. But still 11 has not come to this place. So what do? I increment the data pointer first. So your data pointer will become 8201. Now again I exchange the data because 11 has to come to 8100. So I exchange R5 and accumulator data. Where should I place 11? I should place it in 8100. Where is 8100? In register, it is present in register R1 and R2. Next time I want to use 8201. So 82 will be stored in R3. 01 will be stored in R4. Next, I am going to take the information 81 which is present in R1 to DPH and 00 which is present in R2 to DPL. So your data pointer is pointing towards 8100. The data present in accumulator will be moved to 8100. So in case of AA, you will be getting next 11. So how many data have we transferred out of 5? One data. So I finished one transfer. Next, what I would be doing is transferring the information. So what I'll be doing before transferring, I'll increment 8101. I'll compare whether the data present in the count is equal to 0 or not. I decrement the count because I have performed one transfer. I compare whether 4 is equal to 0. Since 4 is not equal to 0, it will go back and follow the same procedure for the second data to get transferred. So the second data get transferred in the same way how I taught you just now. Similarly, the third data get transferred. Similarly, the fourth data get transferred. Similarly, the fifth data also get transferred. After the fifth data getting transferred, it is going to compare whether after the fifth data getting transferred, it is going to compare whether your R7 is equal to 0 or not. Once it gets to know that R7 is 0, it comes out of the loop and infinite loop will be processed. So this is how you transfer 5 bytes of data from one memory location to another and you exchange the data from 8100 to 8200, 8200 to 8100. So exchanging the data between two memory locations. Thank you for watching this video.